Hello, in this video you will see how to solve a game matrix which is of the form m cross n, where m and n are both bigger than 2. So in this case we will have to use the linear programming method. Okay, but in general, if you see a problem like this, the first step should be to use the minimax method and check for any pure strategies. You will see that in this problem you will find no pure strategies. Then you try to use the dominance method to see if you can reduce the matrix or find the pure strategy. But since no pure strategy, you won't be able to do that either, or reduce it either. And you also won't be able to use the graphical method because m and n are strictly bigger than 2. So if all of this fails, you will have to use the linear programming method, which we will see in this video how to solve. So what you need to do is, when you check for pure strategy, you will see that the maximin will turn out to be -2, and the minimax will turn out to be 3. So now keep this in mind. If this happens, the final value of the game will always lie between -2 and 3. So it will always lie between minimax and maximin, or minimax, whichever is smaller. So now the first thing we need to do in a problem like this is, if the value of the game goes into the negative side, we have to make sure that it comes to the positive side, because later on in the problem we'll have to divide by the value of the game. So it cannot be negative or 0. So how do we push this thing in the positive side? The -2 needs to go to 1. So it needs to become bigger than 0. So we add 3 to all of them. So we get 1 less than v less than 6. So basically what we do is we add 3 to all the values in the game matrix, because we have to divide by v later on. So we add 3 to all the values in this given matrix. So add 3 to 3, 6, -4 plus 3, and so on. So your game matrix becomes, I'm going to delete this and write the new matrix. Now the new matrix becomes, I'll quickly write this. Okay, this is player B. If you add 3 to all of them, it becomes 6, -1, 5. You can verify this when you're doing it yourself. 4, 0, -4, and 1, 7, and 10. Okay, now based on this matrix, we will make the linear programming problem. So we will first try to find the expected payoffs for B. So just like what we did in the graphical method, we say let Q1, Q2, and Q3 be the probabilities. So be the probabilities that player B picks strategy B1, B2, and B3. And then we make the linear programming problem. So now remember, player B will do minimax. So the first equation becomes 6Q1 minus Q2 plus 5Q3. And remember, this expected payoff will be a minimum value because B does minimax. So it has to be less than or equal to all of the values. We'll denote the value by V. So let V be the value of the game. Similarly, the second equation will be 4Q1. You can skip the 0, and it's 4Q3 less than or equal to V again. And similarly, the third equation will be 1Q1 or just Q1 plus 7Q2 plus 10Q3 less than or equal to V. And remember, all of the probabilities should always add up to 1. Okay, so this is the beginning of the linear programming problem. Now, in order to get a value on the right-hand side, what we do is we divide all of these inequalities by V. So divide everything, all three of them by V. So just make a note here, divide everything by V. See, because of this point, we had to add the 3 at the beginning so that we could divide by V, or else if we divide by a 0, it's not possible. But if we divide by a negative, the inequality changes. So this is the reason why we had to add 3 at the beginning of the problem. So now let's see what does the equation become. We divide everything by V. Now remember, if you're solving for player B, it'll be less than or equal to. And if you were solving for player A, which we will do later on, it'll be bigger than or equal to. Because A does maxi-min. All of the expected payoffs will be a maximum rather than a minimum. Okay, so now let's divide everything by V and see what happens. I'm going to delete this again. Okay, so if you divide everything by V, we get 6Q1 by V minus Q2 over V plus 5Q3 over V less than or equal to 1 because we divided everything by V. So we get 4Q1 divided by V minus 4Q3 divided by V less than or equal to 1. And we get Q1 over V plus 7Q2 over V. It's 10Q3 over V. That's not equal to 1. We also divide the Q1 plus Q2 plus Q3 by V. So we get Q1 by V plus Q2 divided by V plus Q3 divided by V equals to 1 over V. We divided everything by V. Okay, now to make this look like the examples we have done, we define, so just introduce a new variable, alphabet, call it, let y1 be q1 over v, let y2, let y2 be q2 over v, let y3 be q3 over v. So all we have to do is substitute the y1, y2, y3s in here. Let's see what happens. So now the inequalities become 6y1 minus y2 plus 5y3 less than or equal to 1. The second equation becomes, now these are the constraints. If you remember the linear programming, these are the constraints that are coming through. Less than or equal to 1. And y1 plus 7y2 plus 10y3 less than or equal to 1. And y1 plus y2 plus y3 will become 1 over v. Okay, so these three here become the constraints of your problem, of the linear programming problem. And remember, player B does minimax, so he minimizes v. He minimizes all of the values that you get. Now, this is another important point to note. This is the same as maximizing 1 over v. So just make a note of this. Minimizing something makes it maximizing the reciprocal of it. So your problem becomes like this. Maximize 1 over v, which is y1 plus y2 plus y3. So maximize this function. Maximize y1 plus y2 plus y3. And these three are your constraints. So you will have to solve this linear programming problem either using the simplex method or Excel. Now what I will do is I will make another video in which I'll show you how to solve this in Excel. So keep an eye out for that. And once you solve the problem with Excel, you will get the values of y1, y2, y3, and 1 over v. So I've done that already. I'm going to make another video for that. But for now, assume that we've solved this linear programming problem. And once you solve the linear programming problem, you will get the value of y1 to be 8 over 43. You'll get the value of y2 to be 5 over 43. And you'll get the value of y3 to be 0. And if you remember, 1 over v was y1 plus y2 plus y3. That turns out to be 13 over 43 if you add the top three. So 1 over v is 13 over 43. So v is 43 over 13. You just take the reciprocal of that to get the value of v. Now this is not the final value of the game. We'll see at the end. But for now, v is 43 over 13. But our main aim was to find Q1, Q2, Q3, not Y1, Y2, Y3. So we go back to the definition of Y1, Y2, Y3. What was Y1? Q1 over V. That tells you that Q1 is Y1 times V. So what is Y1? 8 over 43 times V is 43 over 13. That makes your Q1 to be 8 over 13, which is approximately 0.615. Okay, similarly, our aim is to find Q2. So Y2 was Q2 over V. If you do the same thing, you will see that Q2 turns out to be 5 over 13, which is 0.384. And of course, Y3 was 0. That'll imply Q3 was 0. Okay, so we got the three probabilities, Q1, Q2, and Q3. And we have the value of the game. So let's see what you should write as your final answer. You should say the probability Q1 is equal to 8 over 13, which is the probability player B chooses strategy B1. Okay, similarly, Q2 turns out to be 5 over 13. This is the probability that player B chooses strategy B2. and Q3 0. So there is 0 probability that player B will choose probability B3. Okay, and the value of the game was 43 over 13. So this is where you'll need a little bit of modification. Now remember, at the beginning of the game, we had added 3 to all the values. So it means at the end, you'll have to subtract the 3. Okay, so this turns out to be 43 minus 39, right? 39 over 13, which is 4 over 13, if I'm not wrong, which is around 0.307. Okay, so this should be your answer at the end of finding the probabilities for player B's strategy. And then similarly, you have to do the same thing to find the probabilities for player A. So now let me quickly show you how to make the linear programming problem for that. And then you can use Excel and then use the same methods to find the probability for that. But let's see that. Let's go back to our matrix. Which was 6, -1, 5, 4, 0, -4, 1, 7, 10. Okay, this is player A, this is player B, A1, A2, A3, B1, B2, B3. Okay, so now you say now just make a note, if you were solving this without Excel, and if you were using the simplex method, the probabilities for player A comes from the slack variables. Okay, but since we are going to do Excel, we'll have to redo this whole thing to get the probabilities for player A, but it's not that bad, so let's do it quickly. We do the same thing. We say let, in this case, P1, P2, and P3 be the probabilities for player A's strategy, A1, A2, A3. A1, A2, A3 respectively. Okay, so now in this case, we do the column times the probability. So the first equation of the inequality will become 6P1 plus 4P2 plus P3 bigger than or equal to V. The second will be the second column times the probability, so minus P1 plus 7P3 bigger than or equal to B. Now just make a note, this is bigger than or equal to because A does maximin. These guys will be the maximums of the values. That's why bigger than or equal to. And 5P1 minus 4P2 plus 10P3 bigger than or equal to V. And of course, P1 plus P2 plus P3 will be equal to 1. Okay, so now we do the same thing, divide everything by V. We get, we'll delete this and okay, just hold on for a second. It's recording. Yes. Okay, it's back. So divide everything by V, we get 6P1 over V plus 4. Same thing we're doing. 4p2 over v plus p3 over v bigger than or equal to 1 minus x1 minus p1 over v plus 7p3 over v bigger than or equal to 1, 5p1 over v minus 4p2 over v. We're dividing everything by v, just in case if you're wondering what's going on. Bigger than or equal to 1, and p1 over v plus p2 over v plus p3 over v equals 1 over v. So just like we defined the y1 there, in this case we define the x1 to be p1 over v, x2 to be p2 over v, x3 to be p3 over v. Okay, so your problem reduces to this, which we will then solve it in Excel. It becomes 6x1 plus 4x2 plus x3 bigger than or equal to 1. Negative x1 plus 7x3 bigger than or equal to 1. 5x1 plus 4x2 plus 10x3 bigger than or equal to 1. And x1 plus x2 plus x3 equals 1 over v. So just like we did in the previous thing, these three are your constraints in the problem. And remember, player A does maximum, so he will maximize v. So he will minimize 1 over v. Now we'll solve this in Excel. I'll make another video to show you how to find the minimum in Excel using solver. So the problem becomes minimize x1 plus x2 plus x3 with these three constraints. And remember, once we find x1, x2, x3, our main aim is to find p1, p2, p3, which we did in the earlier part of the problem. And then you also find v. Remember, v in both cases will stay the same. If not, you're making a mistake. Okay, so then you can just finish the problem. Once we do the Excel, you will get x1 equals something, x2 equals something, and x3 equals something. But our main aim is to find p1, p2, p3. So we say p1 over v, p2 over v, and p3 over v, which will give us p1, p2, and p3. So just like this, we will get q1, q2, q3, as well as p1, p2, p3. I will make 2 additional videos in which I will use Excel to solve y1, y2, y3. There will be one video and another video in which I will use Excel again to solve x1, x2, x3. So take a look at that as well, and that will complete the whole problem. Remember, in both cases, the value of v will remain the same, and then you should get the whole answer. I hope this helped. Any questions, you can put it below in the comments.